Okay, so let's power through another paper today. So, 2013, question 1A. For what values of the real number a does the quadratic equation x squared plus ax plus a equals 1 have distinct real roots? Okay, so, well, it's a pretty standard A-level question, right? It's just a discriminant and, and that's about it. Okay, so the main thing to take care is distinct real roots, right? So delta has to be strictly greater than 0. Okay, and make sure you organize the equation properly, yeah? So it's x squared plus ax, plus a minus 1 equals 0, yeah? So that's the only trap, really. So, and then, b squared minus 4ac and so on. Okay, so b squared, now I can't write for some reason, the squared, there we go. So b squared minus 4ac, that's greater than 0. Okay, so now it becomes quadratic inequality, really. So minus 4a plus 4 is greater than 0. So a minus 2 is greater than 0. And, what happens here? What happens here, right? It's quite interesting. So it's sort of a perfect square. And, perfect squares are always greater than 0, right? Except when a equals to 2, right? Except when a equals to 2. So if a is not 2, then it's fine. Then it's always true. Then it's true, right? So, well, that gives us our answer straight away, really. It's quite a simple question to start with. So that's A, okay? So as long as A is not 2, then the equation will, have distinct real roots. And, let's prove that. So, what happens when x is 2? Well, then x squared plus 2x plus 2 equals to 1, right? So, it becomes an x plus 1 all squared equals 0. So it becomes a repeated root, right? It becomes a repeated root. So minus 1 is the repeated root here. Okay, so that's correct. Okay, so A is not 2. Cool. All right, next question.